Hi, everybody, and welcome to today's interest session. Today is the topic is Introduction to Cybersecurity as a Career. And the goal of this seminar today is to not just kind of educate you and inform you on the reasons that it's a career today, right? Versus just an interest or something or a hobby, years ago. The reason it's actually an entire career path today and the need for it to give you an idea of the cybersecurity landscape, what's happening, and why we need it. And on top of that, to give you kind of the background on the different positions and the titles and the responsibilities of the different jobs that are available, some salary ranges, things like that. But also to let you know and show you, demonstrate to you some of the actual technologies that you'll be expected to know and learn and use on a regular basis for things like network design and packet sniffing and network mapping and things like that. The intro sessions are given to you from coming from the ETIC. The ETIC is the Entrepreneurship and Technology Innovation Center. I am Dr. Nizich, your host, and I am the director of the ETIC. I'm also an adjunct associate professor of computer science here at New York Tech, and quite frequently in a number of different magazines and articles for cybersecurity kind of topics. Those of you who don't know, we have an ETIC in the Long Island campus. We have an ETIC in the Manhattan campus on the 6th floor. Each of those campuses are configured with some cybersecurity equipment that we call a sandbox that you can actually get your kind of hands dirty with and get your hands on. And those of you who don't know, we are prototypers. We build different technologies. Some of them were cybersecurity technologies that we built over the past year and a half or so. And we have contracts with NASA that we operate out of the ETIC for. So just a quick little kind of pitch as far as what we do and where we are and kind of what we work on. And that's our lab, some pictures of that. And kind of when we put it all together, with students like yourselves, it's pretty magical and we have a pretty good time doing it too. So come visit us when you have a chance. We'll kind of let you know how to get involved if you're interested. All right. So cybersecurity, why is it a career? I mean, let's talk about the jobs themselves. If you look at some of the jobs themselves, they're pretty solid salaries and pretty good career paths and pretty lucrative. Once you get into the leadership roles, they're incredibly lucrative. Once you become like a director, middle manager of cybersecurity designing, like in this case, an architecture designer for networks, for secure networks, or if you get into the deputy chief information security officers, the second in command positions are extremely lucrative. The chief positions are unbelievably lucrative. So it's a really, really good, solid career path that you really, once you get into it, as long as you enjoy it, it's not something you're going to have to get out of. It's not just a flash in the pan type of technology. The number of jobs that are available is enormous, and it's really incredibly hard to find people because of the skills that are needed. So this is one of those technologies. This is one of those career choices where you really truly have to, more so than any other type of career path, have to really do and show what you say you can do before you get hired, right? They want to put you in action right away because there's so much to do. All right, so let's talk about something called the workforce gap. And we'll talk about why there's such a big gap between education and the actual career needs, job needs that are out there. So a few kind of high level things to put you into the cybersecurity kind of arena. We have breaches and we have methods. So every time you read about a breach, there was a way that they did it, an MO, modus operandi. There was a process that the attackers used to get into a system and to infiltrate that system. So the breaches that you hear about are usually the company names or the organizational names. The methods are the things like Melissa, my do, want to cry, I love you type things. Those are the actual attacks and the approaches that they use to do. Sometimes it's just software. Sometimes it's software combined with social engineering to get the software to run. And these are the things that we kind of always hear in the news. Cyber is not new. Cybersecurity has always been an issue. We just never really had it as bad because we never had networking before, right? We never had the internet. We never had all these different devices back in the day. Cybersecurity has been around for a long time. It just didn't have the actual importance that it does today because we're all connected versus just a very important government computer, right? Today, everything's connected and all the data that we transfer over these devices is valuable in some way or another. The IoT is really, Internet of Things is really the driving factor here, is to say that we can secure networks in a lot of ways, and we can protect networks with encryption and cryptography, and we can protect our devices with virus scan software and things like that. What we can't really protect are the IoT devices. They're small, they're simple, they don't have the bandwidth and the ability to run real hardcore security software and kind of protective measures. So our IoT and what we call IoMT, Internet of Medical Things, these two different networks where we're hooking every medical device in a hospital up to a single network. We're hooking every device in our home up to a single network. These devices that are access points to your network aren't able to run the same security that your PC or your laptop or your tablet or your iPhone can do, right? So they're just not powerful enough. So these access points are really the weak link in the chain, and that's what's driving a lot of this kind of need for experts in the field. Keep in mind how old this is. We connected 4 computers together in 1969, some called the ARPANET, and now we've got, this is a dated presentation I'm given by a few years, and we're up to, well over 20 billion devices connected now. Each one of those devices is a pathway into every other device on the network, which means that we have all these vulnerabilities out there that we have to kind of keep an eye on, and we have to kind of make sure that they're not being capitalized upon by the bad actors. So the other piece to this puzzle, why people want you to be a cybersecurity expert and work for them, is that there's a marketplace now, right? There's actually a mall. There's a cyber mall called the dark web that people who steal data can actually go and sell the data, really with very little chance of getting caught. And this existing marketplace that now is available to sell and find buyers for your stolen data is one of the driving factors. So we have that all these computers getting connected that never were before connected. We have all these weak spots in the networks that are being just thrown on the networks and not really configured properly, not even able to be protected because they have kind of weaker operating systems, very basic operating systems. And we also have this marketplace now for creating demand for stolen data, right? So this creates like a perfect storm that basically leads us to thousands of successful attacks, not attempts. The attempts are impossible to number. There's just a constant number of attempts. The number of different successful attacks are high. The loss of money, meaning that the money that equates to the data that's stolen, but also the amount it costs to repair. It's not so much that you would quantify how much is stolen, it's the cost of the repair, right? I've been in Newsday 3 or 4 times now for this Suffolk County hack, this this ransomware attack, just being interviewed for, as an expert kind of in the field. And, they're into $14-16 million already in costs and they're still not back up. It's almost, 4 months, a little over 4 months since they got attacked. And now they're still juggling this, right? So it's an enormous amount of money. And the recovery time is sometimes it actually puts a business out of business. And what you see an unbelievably large amount of jobs being open positions. Okay, the positions that are open in this case, roughly between 1.8 million and 3.4 million, depending on what source you look at. Government and corporate have different, kind of conflicting numbers, but overall, it's definitely in the millions. They're unfillable. They can't find enough people coming out of school, transferring over from other parts of industry, and learning the cybersecurity skill sets specifically that are going to allow them to work in this field. And what happens with that is that you just can't find people that you're willing to hire. So it's not that you're going to just kind of walk out of school and go into a cyber job. You're going to have to show but there's a path and there's a need for it. And they really look for problem solvers, critical thinkers, and such. So, right, how do you get started, right? That's one of the things. New York Tech happens to be a center of academic excellence in cyber defense education. It's an NSA designation. Our programs, once you go over into the IT program with a concentration in network security as an undergraduate, the computer science program and a concentration in network security as an undergraduate, into our cybersecurity, it used to be called INCS, but it's the cybersecurity master's program. those programs, you're graduating with a designation from the NSA. So that should be noted on your resume. That should be noted on your transcript. And the fact that you have that concentration, you're coming out of a school that the NSA has said, we in the Department of Homeland Security and Department of Defense has said that if you come out of this school, you are, you are supported by us. There's other schools in the area. Each one of these schools are designated as a center of academic excellence in cyber defense education or research. So really anything that you want to do in the area, as long as you go to one of those schools, those programs are supported. What does a program look like, right? In general, it looks like, kind of a lot of different computer science and understanding computers and networks and security parameters and why there's threats. And then there's also kind of high impact practices and scholarships available that people go for each year and get their hands kind of dirty and kind of in the mix, right, of designing networks and configuring things and writing software and such. So there's all kinds of ways to do that. When you're considered as an applicant to jobs that have open cybersecurity positions, they look at two things, right? They look at your experience, your work experience. They look at your college experience, of course. Do you have an associate's degree? Do you have a 4-year degree? They look at what that's in, right? If you have a psychology degree and you're moving over into cyber, it's totally possible, but you have to show like how you move from there. But if you have a technology degree of some sort and you're moving into cyber, it's a really strong start, that you have that. The other things they look at are professional certifications, right? The certifications are so focused and directed, and they're exams that are structured around you taking the exam and passing it and telling the organization, the company that you're looking to work for, that I know what I'm talking about. There's a few that are basically, kind of accepted and looked for. CompTIA is an organization that gives these, some of these. The 3 tests that they have, the 3 programs and tests that they have, the exams they have are Network Plus, A Plus, and Cyber and Security Plus. A Plus is the certification that you get to show them that you know how a computer works, how networking works in general, how software and hardware interrelate with each other, and the inner workings of processors and memory, and that is a core in understanding that you'll need to know. The Network Plus will take you to the next step of knowing how a computer works, but then knowing how 2 computers communicate with each other, where you learn the TCP/IP protocol stack and everything else. And then Security Plus is focused on security, on how to secure the computer from the stored data perspective, from the transmittal data perspective, information stored in memory, right? So Security Plus will teach you all the different parameters on user and group security and such. So those are 3 big ones that you would want to look at. Another organization called ISC Squared, which is the leading cybersecurity professional organization, has a bunch of different certifications that will take you from the executive leader position, which is CISSP. That's one of the ones that I hold, and all the way through a very, very specific certifications like cloud security and healthcare security, architecture and security engineering, like building networks, secure networks. So all these different ISC Squared, which is it's just how you pronounce the organization name. The ISC Squared organization, all these certifications, each one will show somebody that you know a whole heck of a lot of information about a certain topic, right? And that's kind of some of the ones that are there. Now, every time, the way the government works is basically, the way cybersecurity works is that basically there are frameworks, right? There are frameworks that everyone follows, right? One is called NIST, one is called ISO 27000, another is called COBIT. These frameworks that tell you how to secure your network to make it to keep it protected. You are basically configuring a network for a company in one aspect of cybersecurity to protect that network, or you work for an auditing company that's supported by the government that says, is this financial company truly protected? Is this healthcare organization truly protected? Right? Is this educational organization truly protected? Each one of those types, financial and healthcare and education, they each have federal laws that basically force them to protect their data in a certain way. And if something happens, like a breach, they want to know why it happened and if they were at fault. The auditing companies have professionals, cybersecurity professionals like us, that go in there and do audits to see if the companies and the organizations are truly following those. Those audits lead to fines and other stuff. But you have two different sides of the fence. One is that you're the IT person and the cybersecurity expert who's configuring networks to kind of protect an organization. The other is the person going in and making sure that that person is doing what they say they're going to do. These two different perspectives of cybersecurity are what is driving all these jobs, right? On top of what's driving all these jobs is the fact that people really truly are getting better and faster and stronger about breaching networks and stealing data, and the dark web keeps growing. So it's this big ugly engine that just keeps growing and growing and growing to try to fill these needs as things arise. You are one of the solutions to those needs. Okay. So what does it look like? What do you do for a living, right? What is your title? You're a security analyst. You look at different levels of analysts, take different levels of threats. But when you're working on a network with thousands of computers, those computers behave in a certain way. They have a certain kind of behavior or signature on how those computers are used, how people use those computers in an organization. There are software systems that basically sense anomalies. They say that this computer is not acting properly like we expect it to act, so go check it out. The analyst looks at all those different things, right? Sometimes an analyst looks at every computer in their organization. Sometimes they work for an organization that manages hundreds of other organizations. And as these alerts come up in all these different organizations, they go in and start to analyze, is this really truly an alert? Should I look at it? Should we shut the machine down? Should we take it off the network? How serious is it? You have to understand all the components of a computer. You have to understand all the components of the networking, all the components of security, all the components of software, all together, so that when you see an alert come up on Joe Jones's machine on the third floor of a finance organization, you could be like, no, Joe is probably just landed on a pop-up message from a car dealing site or something like that, or Joe is actively being polled for by an attacker to see, trying to get him to answer a phishing email, right? So you have to look at the alerts from the systems, from the logs and things like that, that are telling you something's going on. So the analyst is like the most active and most popular job. And the better you are as an analyst, you move up through analyst level 1, 2, and 3, and then you become a manager of all the analyst departments. But basically, the analyst is what is looking at all this data coming in, and figuring out, is it really a threat or not, and if so, what do we do about it? And the security engineer is actually doing all the different analysis, but they're also doing the responses. They're actually figuring out how to handle this threat and what to do next. And if we do this, if we take the system off the network, what is really going to happen, right? The engineer has the ability to do all the fixes and the actions, but they also know what effects, positive and negative, it's going to have if they do them. The architect is the security architect designs the networks. They say, look, I'm a new architect in this organization, and in this organization, they have a real vulnerability here on their firewall. It's my job to fix that. Here's how I'm going to fix it. And that's an enormous amount of knowledge to have, but it's also a very specific job where you're not looking at the regular day-to-day kind of activities. You're really going in and fixing, and designing the system to be secure from the start. Security administrator is all the users and groups and permissions on folders and everything. It's very, very interpersonal, where you're working with a group of employees at the finance level, working with a group of employees at the HR level, and you are figuring out what they need access to and why, and you're figuring out how do you give it to them so that they can be more efficient at their job, but also how do you limit it so that the information doesn't get out and all that. So the security software developer it's two things. One, if you work for a software company that builds software, you are making sure that software is meeting the requirements of secure software, which means that you're not allowing code to generate buffer overflow errors from the outside. You're not allowing code to allow SQL injection errors from the outside. You're making sure that the programs that are designing the code are doing it in a certain way that meets the criteria for secure software. Okay, and that's one of the things you do. And then you have cryptographer and cryptologists that basically, from a mathematical perspective and a design perspective, think about new ways to protect data, right? New ways to generate new algorithms that will protect data over time. A very specific type of job. Cryptanalysts will look at data that is acquired during an analyst's kind of review of a project and of a problem, and will figure out what was done to change this data, to alter it. Was it altered on purpose? Is the cryptography that we're using doing a proper job? And all kinds of things. And then we have a chief information security officer, which is the leader of an organization. You have a chief executive officer, a chief financial officer, chief information officer, but the chief security officer is the top leader, and leading all the analysts, leading all the architects, leading all the designers and cryptologists, and basically saying, look, we have to make sure that this organization is operating at the securest level possible while making sure that they have the most efficiency possible. It's a very, very hard job and a very hard mix, but you have to open up as much as you can to make people kind of work as efficiently as possible and keep them happy, keep them productive. On the same note, you have to secure that network at the same time. Right? Then you have security consultants and specialists, where you actually can wind up, just acting as a consultant in a part-time, almost like your own business, where you know so much and you're just kind of alerting, companies and organizations that have the need for it. Okay. There is a document that you should be aware of. It's the NICE Cybersecurity Workforce Framework. This framework is a government framework that they kind of keep making kind of adjustments to, but it's pretty neat. It lists every different type of cybersecurity job and the actual skill sets that are required to meet that job. So you're able to kind of use this document and say, if I wanted to be a security analyst, what do I need to know how to do? And if you look at something and you say, I don't know how to do that, then learn it. Go through and get that experience in doing that. These are actual job titles that you see, like when you go to Indeed and see that job, right? So if you're like, wow, cyber defense incident responder, I kind of want to learn about that. Maybe that's me. Personality-wise, maybe that's me. Learn about it. And when you do in the NICE framework, it's going to tell you every different specific skill set that you'll need to show to qualify for that role, right? It's a really neat document. I recommend it. Right. What do we know? We know we're moving towards 20 billion, or even surpassed it so far, connected devices on the internet. We know that the customer demand for the ease of access to data and increased mobile usability will continue to increase. We know that as customers, we keep asking our banks and our websites and Amazon and us to give us more, right? Give us more freedom. Our demand for that is never going to stop. We're going to keep asking our providers for more and more stuff. Otherwise, we're going to go to another provider. And unfortunately, we're causing a lot of the problems that we see in our demands. But it's not going to stop. We all want more. We know that there's a formalized market for the existence of stolen data called the dark web. Never had that before, and now it's actually structured. You can go to it and not even be tracked, and that's out there. So we know that cybercrime has been and will always continue to increase, possibly exponentially due to mobility. So people are committing crimes now, not at a physical location. They're committing crimes in remote locations that can't even be tracked. So it's not just that you can spoof your IP address or your MAC address, that people don't know who you are and what device you have. You can actually do it from somebody's house three neighborhoods away, because their Wi-Fi is open. Sometimes the damage they do from an identity theft is actually way worse for you life-wise. They're affecting your credit and your ability to live your life over longer periods of time, and not just the one incident. So in a lot of ways, it's actually worse than some of these horrific crimes you kind of see all the time. So we know that we are formally training people like yourselves. We're formally training them in topics like ethical hacking, pen testing, and in hopes of creating a cyber workforce. I mean, we know we're doing that, but we don't know the outcomes of that. Hopefully it's a good thing, but again, we've never taken groups of people before and trained them how to do this so that they can stop it, right? Well, hopefully they do stop it. I hope they do. But on the same note, the entire world is doing this. They're training people in the cyber attack methods so that they understand how to stop them. But it's very first time we're seeing it. What else do we know? We know the gap between cyber jobs and skilled workers is expanding. It's never come back. It's never come back even close to even all the work we're doing, all the efforts we're doing. We still can't. The gap is just broadening and broadening and broadening, and it's really unstoppable. We're barring some paradigm shifts that I'll talk about in the next slide. We don't really have an answer for filling the gap. And finally, we know that if it's not addressed, the gap in the workforce is going to lead to a rampant, uncontrollable theft of personal information, intellectual property, and corporate data. So That's what we're worried about. We're worried about enough people going into cyber and becoming good at it, not just going into it, becoming good at it so that they can counteract some of the efforts that are going on in the world. So let's go to the next one, and just some quick ones, some things we don't know. We don't know if the increasing available jobs in cybersecurity is going to entice people to change careers. We don't. It's not something that like, oh, there's a lot of jobs here, so I'm going to change my career. I like my career. I don't want to. You're going to have people that are just going to stay in their career and not move over. So it doesn't matter how much you do or how many jobs are available. Somebody's still going to choose to go do something or not. So we don't really know if that's going to happen the way we think it's going to happen. We don't know if people changing their careers will have the skill sets to be successful in cybersecurity, right? It takes a very special person, right, to do this and to be good at all of it so that they can actually make a difference. And that's why we're seeing more jobs being opened and not being filled. We don't know what the continued sophistication of cyber criminals means to the future of cybercrime. So there's more people becoming great at cybersecurity on the dark side than on the good side. That's what we know. We know that there's a lot of people going to school for it, and there's a lot of people kind of learning it, but there's a lot more people globally that are just getting fantastic at it because there's an easier, darker path, right? Sounding like Darth Vader, unfortunately, but there's a darker, quicker path to using cyber. So they're getting better at it faster than the good guys. We don't know what the technological future will bring with regards to paradigm shifting technologies. And what that means is that, I use the light bulb as an example, right? So years ago, we had candles, right? And we had candles in the street, and you had a whole bunch of workers that had the little candle sniffers, and they would kind of like light the candles every night on a big street, and they would put them out every night on a big street, and little kerosene kind of lamps type of things. And that's where we got a light from, right? Before electricity and before light bulbs were not so long ago, a couple, 150 years ago or so. And, that's, we couldn't find enough snuffers, we couldn't find enough, light lamp, people that go and light the lamps. The more streets we had, the more lamps we had, the bigger the cities got, the more lamps we had, and they had to get lit and put and refilled. And we couldn't find enough people to do it, And then electricity came along, and none of those people had jobs, right? Not only did you not need new ones, but none of the existing ones had jobs. Like overnight, like as soon as the cable got ran in, as soon as the light bulb replaced the lantern, that entire street, whoever's job it was to handle that, is out of work, and there's no more issues in finding people. So, this paradigm shifting technology, we don't know. I mean, maybe it's blockchain, maybe it's some other technology that we don't know about yet that's going to come along. That the cybersecurity issue is just not going to be an issue anymore because it's just the new way we do things, right? We don't know that. It could, but there's nothing in sight really that's going to magically take over TCP/IP in our communications platform. That being said, let's talk about some of the things you're going to have to kind of work with in industry. There's a operating system called Kali Linux. So Linux is a operating system just like Windows, just like a Mac, just like iOS, right? So an operating system is the software, the kernel we call it, the kernel that basically controls all of the different components of a computer, the actual memory and the hard drive, and that's the operating system. The operating system is how files are structured and stored and sorted on these devices, how the devices are managed, how data gets from these devices and memory into on the monitor and in the keyboard. So just, the operating system, lots of things are thrown into Windows that seem like they're Windows, but they're not. The operating system is always considered, the functionality of that. So Linux has a bunch of different distributions, we call them, or versions of their operating system. And because it's open source, you can take a Linux operating system and customize it and then call it your own operating system, right? That's one of the beauties of it. So the Kali Linux version, the distribution of Linux, is specifically designed for cybersecurity professionals and experts. And it's designed in what we call pen testing or penetration testing. It's designed as an operating system that's a series of tools to actually get from your computer to try to test your network and try to test your file servers and things like that. the caveat here is that it is an operating system. It's not a piece of software. So if you try to download it, it is free and you can download it, and it is something you should have experience with, but it will basically replace the operating system on your computer. So a little caveat is, before we go forward, this is no recommendation or anything to do this, but you have to know it exists, right? So basically, we'll go through some different kind of components here. And before we do that, before we get into that type of discussion, understand that there are laws, federal laws that basically, and state laws that basically forbid you from doing any of this on any other computer but your own, right? So if you're on something that you own, you can do whatever you want to. But if you, this second that you go into some other computer without getting formal written documentation of that, you are breaking a federal and state law. So understand that, and understand that the building your own network with your own equipment is highly recommended, and you can do anything you want on it. But as soon as you say, "Oh, let me just do what I did at home on this network," that's when you cross that line. Okay. So, all right, let's talk about networks. So what we're really talking about with cybersecurity is we're talking about networks of computers, right? Computers and wireless devices connecting together through these devices called switches, and the routers connecting them to the outside internet for all these other networks. And that's how we can all communicate together. But the goal of a cybersecurity kind of attack is to get through the internet, from the internet through the the forward-facing router, into what we call a TCB, or a trusted computer base. Once the actual person gets from the internet, from the outside world, we have Russia, Nigeria, North Korea, Poughkeepsie, New York. It doesn't matter where you're from, but here's the ones we hear in the news all the time, or nation state actors. But once we get into the network, we're pretty free. Once we get into the network past the router, you don't see a firewall here because we didn't really talk about that in this one, but the firewall is a very strong device to protect anybody from the outside getting in. It goes between the router and the network. But basically, like, once you truly are in the network, you're pretty free to roam around as you wish. There's things you'll have to do to take a look at different devices in different areas. But overall, once you're in the network, device-wise, you're pretty free to roam around on devices. Now, each device might have their own security setup, so that's harder to get into and all that as an attacker. But pretty much what the goal is of an attacker is to get into the trusted computer base, and then they'll figure out the rest. But once they're into the TCB, then they have ways to figure out all these other areas, but getting in there is the hardest way. The easiest way to get into the network is through something called phishing or social engineering, learning enough about a person and then trying to figure out kind of how to let them let you in, right? So they send emails with scripts that basically, if the person does run it, says, "Yes, I'd like to win $1 million, and yes, let me click on it now." That script will let them into the trusted computer base. Okay, so that's the goal. We also have something called the OSI model, which we really call it the TCP/IP model now, because the OSI, Open Systems Interconnectivity model, this is kind of a little dated, but it was what we used for years and years and years. And now we're just using a TCP/IP model, which is essentially this, but in 5 layers instead of 7. But we have to have a way for the physical layer, the actual cabling that actually connects all the computers together, the physical cabling all the way through the application that you're using, a Telnet, FTP, or SMTP, whatever application you're using on your computer to communicate with other computers. There's levels, little pieces of software that take each message that comes in and break it into these things called packets and frames, and basically move it up the chain. This model and what level you look at data at is important, because that's when you know that this is a session layer attack, this is a transport layer attack, this is a network layer attack, this is a physical layer attack, right? We have to know kind of what layer somebody's looking at when they actually try to infiltrate something. But and then we have in cybersecurity, we have the CIA triad. We have confidentiality, integrity, and availability. So data that's sitting on your network, you're trying to protect. You're trying to keep it confidential, so people who shouldn't know what's in the data don't know it. Keep the integrity of the data, so that if you're looking at dates and times and salaries, that they are dates and times and salaries. They don't get screwed up so that the date doesn't make any sense, the salary doesn't make any sense, and so forth. And availability. Do the right people at the right time have access to that data, right? We combine that with something called the Macomber Cube, or the CNSS model. Committee on National Security Standards, and basically the CNSS model or the Montgomery Cube, as we call it, takes each of the CIA triads and meshes it with when data is being transmitted, when data is being stored, and when data is being processed, and what technology are you using, what policies you have in place, what people are using the system. So we use this cube to basically say that when we're putting a new server in, how are we managing the confidentiality, integrity, and availability on that server when we put it into the network? But also, how are we managing that when that network, when that server transmits data, when that server stores data, when that server processes data? How are we protecting that server when we add technology to it? What are the policies we're using to train people on that? What are the people being provided security wise to that server, right? So we look at the cube every time we make one change on the network. From an architect's perspective, we're going to put a new switch in, we're going to put a new router in. We look at all the aspects of the cube to say, have we looked and covered everything to see how this is it going to be a successful install or not? All right, then we have operating system. We just went over this, but basically we have different operating systems, and those operating systems, and as far as Linux goes, we have the bootloader, the kernel, the initialization system, the daemons, the graphical server. So each different Linux component of a Linux operating system plays a role in allowing it to manage that particular device that is on there. With regards to Linux, you'll see that the distributions of Linux are many different versions that you can use for working in your office, for running a small device. You have all different types of versions of Linux that you can use. The version of Linux that we use for cybersecurity is called Kali Linux, and it's created and managed by Offensive Security. So there's always updates to it and everything. And basically, when you open Linux and you open the operating system, very similar to every other operating system, the difference is in the tool set, okay? In the tool set of Kali, everything's broken down into sections, right? Information gathering, vulnerability analysis, web application analysis. You won't see any other operating system in the world give you the core tool set that Kali gives you for cybersecurity, okay? So if you're going to be a cybersecurity analyst, expert, professional, even down this track, Kali Linux is this system that you will be asked to, or really be expected to know exists, have experience on it, know the tools inside of it, and know its purpose, not just its uses. So basically the categories that you saw in there, if you look at how they're broken out, right? Information gathering, vulnerability analysis. We want to basically look at systems, right? We want to basically look at computer systems and figure out what's happening with them, okay? Are they safe? Are they secure? Before we launch this new system on the web, right, or on our local network, is it secure? Is it up to, is it up to stuff as far as what we expect it to be? If you're working for an organization that's hired to audit people, you'll use Kali to basically figure out if a system is vulnerable to certain types of attacks. Then you report that in your report on the auditing side. Okay, the tools themselves are programs like anything else. It's like an open source system. A bunch of people get together and write a really good, useful tool. It's evaluated, it's analyzed, then it's added to the toolkit. So now you have over 200 tools that have been built over the years that are available to anybody who downloads the system to utilize in some fashion. Okay, and what you should do is you should go into the Kali website. You go to the tools, and each one of these not only allows you to use the tool. Once you have Kali, it doesn't allow you to use it from the website, of course, but it'll give you a description of what it's meant to do. So air crack for cracking and testing, more than cracking, but testing wireless networks. What type of encryption? If you're using WEP, it'll tell you right away that this is a vulnerability. There's a couple of tools for testing passwords to see if people's passwords are kind of up to speed. There's tools that will actually provide you with passwords to systems that you're locked out of, right? There's all kinds of tools in here that are useful to network administrators and cybersecurity analysts. Unfortunately, with a free download and free implementation, there's no stopping the bad guys from getting it too. So everybody, good and bad, uses Kali to basically to basically kind of do their part of the job. So Kali's available, kali.org. You can kind of pick your operating system. You basically can implement Kali on a server or workstation based approach. You can actually have a workstation that actually runs that operating system, and it's just part of it, and that's what it is. You can have a dual boot where you go into Windows and you go into Kali. But the cool thing about it is that you can actually configure a USB drive, and this is the way a lot of us do it, that the USB drive has a certain version of Kali on it, that when you boot off of the USB, you're using Kali, but you have access to everything that PC has. So let's say you go to a PC on your network and you boot with Kali Linux versus going to the real operating system, you're still running Kali on the network. So you actually have access, there's the network, but with Kali. So a lot of times that's the way we do it. We boot off a USB and then we're using Kali, and then we reboot the computer and it's back into Windows, and it saves us from having to plug in a laptop into the network and risk the laptop getting damaged and things like that. So there's a couple of different ways to implement it. The way you create an actual bootable USB is you can use a tool like Rufus. There's a bunch of them out there, but Rufus will actually configure a tool, a USB key with an operating system you can boot off it. Okay. With any of these seminars, I always make sure that you're aware of the ethical hacking. There's 10 principles of ethical hacking that we looked at, right? That we kind of use. Right? I will respect others and not use information to harm another organization or a person. I will be honest and ethical and moral, right? You can go through all these, but keep in mind, not only is what we're talking about illegal if you do it on anybody's system but your own, there are also, social and human and moralistic topics too, right, that you need to consider. You risk, every time you do this, you risk doing damage to something that may affect its CIA triad, right? The confidentiality, integrity, and availability of what you're doing it on. So it's not something to take lightly or to toy with as you go through it. We will get into a couple of different kind of demos of some software that you'd be exposed to. So there's a couple of things that happen on a system. So when you're on a Windows system, as an example, we're on a Windows server right now for our training system. And what you do is basically when you're in a system, every system has some sort of a command line. Basically, what we wind up doing is we wind up looking at something called an IP address. And when we look at an IP address, that IP address is an address that uniquely identifies that machine on that segment of the network. So if we wanted to see if that address was actually running on that network, we could basically just ping that address, and we can get a reply from that in 32 milliseconds that we know that network is now communicating properly. Okay. Again, it's my IP address, but I could ping something else on the network. But essentially, that gives you an idea to see if something's on the network. There's also something where every computer that runs software, which is all of them, run that software on something called a port. It's a number from 0 to 64,565 or something like that. And every single number can run one program. And what happens is when one program talks to another program anywhere in the world, they talk over some sort of a program application running on a certain port. So those ports actually transmit data. Think about it like a little tube, like a little tunnel, and only that port has that data. So when two programs run, they run over a certain port and communicate with each other. So we can choose to listen and look at data on a certain port between two computers, or on a computer between itself and it's another application or whatever. But that's generally how all software works on all computers, is it runs through ports so that nothing else gets in the way of that transmission. So different applications can send data over different ports, and they don't ever confuse each other because they're running through these little straws, of communications. So if we were to go to Netstat and we were to show all of the different ports on a computer, there's TCP, which requires a response, transmission control protocol. Those are the things we're used to for the TCP/IP model, that we have to have two-way communication to keep something going. Otherwise, you get a bug, you get an error. But there's other applications called UDP, which we don't, it's called a datagram. And basically, sometimes we're in like mountainous areas, or we want to run a program that's not going to crash if it doesn't get a response, but we want it to be a little bit more, flexible. So it won't work all the time, but when it does work and it can work, it will. So those different applications run on ports that are on UDP ports, and everything else that we know has to have two-way communication to function, which is almost everything we do, is TCP ports. But we know there's a lot of common TCP ports. 443 is an SSL port, a secure socket layer that we operate secure. Port 80 is regular internet traffic, which is unencrypted traffic. These ports that you see running, we know that there's applications running on those ports. And if those ports, right, 1433 is SQL Server, so we know that these ports represent that software is running and listening, which means that is a potential vulnerability to anyone else. What we want to do when we go onto a network is we want to basically understand what that network. We want to basically understand what is on that network from whatever machine we're on. If we're on a machine and we want to see what's on that network, we basically can take that particular IP address, and we can learn about that machine, that particular machine, or that network segment. And what we can do is we could use something called ZenMap, which is a mapping tool, and we could put in a particular address, and we can run something called a simple scan or an intense scan or a quick scan or whatever it might be. And it kind of gives us a little bit of, but it's going to tell us all these different things. Like it knows that this computer is running all these different services, right? And I'm on this local computer, so of course, that I know this because I'm on this computer, but it doesn't have to be. I could go and scan something else on my network, and it would still tell me there's some computer behind locked doors down the hall, whatever. It would still tell me what that computer is running. Okay. And we need to know this as good guys. We need to know this as network administrators to be like, ooh, this computer is running VNC. That is not a good thing. We don't want that VNC port open to access whatever it might be. This computer is running PPP. It's running Squid HTTP. It's running MySQL. It's running. We don't want that particular server to run that information if we consider it vulnerable. But by doing those types of searches, it tells us roughly what what vulnerabilities might be on that machine. We use these things called ZenMap for mapping networks. We use something called Packet Tracer for designing and testing networks. So rather than work on the real network, we can actually design different networks, and we can put different networking equipment. We have a whole interest session on this in creating networks. So you can actually watch that on our YouTube channel, and you can kind of design networks. And once you design the networks and once you connect those networks, you can actually use that network live. It's not just a mapping tool that'll design like an actual diagram of it. It's truly a network that operates. So you can actually wind up sending packets through your network. You can actually send packets through your network and see if those packets are going to go through. And you'll see it's kind of got no, the way we configured it is kind of haphazard here. But in using these particular tools, you can design networks and test them before you actually roll them out. You can design networks in Packet Tracer and make sure that they're going to function the way you want and be secure, and then issue commands to your staff to go and build this network, right? So we use the network tool for that. We use TCP/IP works something called packets. Packets are chunks of data, chunks of larger messages. So if you have a Word document with 1,000 words or whatever, that's sent outside of your computer. It's sent in larger packets. So there's thousands and thousands of packets that all get put together at the end to get that message from your computer to somewhere else, someone else's computer somewhere else in the world. But those packets have to get put together. We can see packets. Packets are very public. Packets are you can see them over wireless, you can see them over wired networks. There's nothing secret about packets. What's secret is the data inside that packet should be encrypted with what we call AES advanced encryption standards, like something called RSA or MD5, like a hash algorithm or something like that, something that's an acceptable, powerful encryption algorithm that really is proven not to be vulnerable. Now, if it's not, then all those packets are able to be seen. So what we have the ability to do is to do the same thing where we basically looked for a basic device on our network. And what we can do, let me see if we can take this filter out. And what we can do is we can listen to all packets flowing over a network, right? We can listen to in something called promiscuous mode, where we see everything everywhere, or we can listen to one particular machine. And then what we can do is we can filter, right? We can kind of filter only what we want to see. So if we suspect that Joe's machine on the third floor is between 2 and 5 in the morning, we get a lot of complaints or whatever, we see a lot of traffic, we suspect that some sort of a virus is kicking off on a timed, routine from Joe's office. So we have a lot of information that as an analyst we figure out, but now we have to have tools to look at that and say, look, there's too much data. We'll never be able to see it just by looking at Joe's computer, and there's too much information to go through without having software to filter it out. And that's what we use. We use toolkits. These toolkits that I'm showing you now, they're all part of Kali Linux, but Kali has a whole bunch of other basic information, basic tools that are useful in so many different ways. The best way for me, that I like to look at cybersecurity is, if you've ever seen the cable that goes into your house, the coaxial cable, the black cable with the thing, and it screws into the back of your modem, right? If you look at that cable, all you see is the cable. You don't see all the, right? Look at what's flowing through that cable. It's not even if you cut that cable and you saw the copper and the plastic inside the shell. It's not even that. It's the fact that you can't see all of the data that makes up your television show streaming through that cable, all of the data that you look up on the internet, right? You don't see that at all. You'll never see it with your eyes. You have to build some sort of frame or model of what that data is and then use it. That's what cybersecurity is to me. You basically are looking at things physically, like networks and routers and whatever, but cybersecurity is about what is flowing through those, right? You have to be able to conceptualize how to break all that data out, compartmentalize it, and make a model to say, this is what's happening because this data that's invisible, really, this data is showing us that most likely a high probability that this is what's happening. And then you apply the fix to stop that. Okay. For those of you who are watching this on YouTube, I'm glad I hope you enjoyed it. I hope you learned a lot, and I look forward to seeing you at future interest sessions. Okay.